Hello, science fans. Welcome to another episode of Science TV with Mr. C. Again, I am your host, Mr. C. A couple of things I want to talk about today. First being the grade book. You might want to go through that and check it to make sure there's no zeros for this 9 weeks. This is really a lot of the stuff you're doing is based upon completion. So if your grade is less than an A, you should probably look at the grade book and see why that is. Secondly, I wanted to talk about an activity that we did. It was due Monday, called the cost of electrical energy. I noticed a lot of us really didn't answer that correctly. So we had the power rating of various appliances in your home, and you were supposed to estimate how much it was used a day and how much does it cost a day. Problem is, you were doing things like, let's say we used your microwave oven for an hour a day. So you were putting 1 there. And they estimate the cost of use. Most of you were saying 10 cents, like it says up here. So you were taking 1,500 times 1 and getting the cost of that. And you were saying to run your microwave every day, it was costing $150. That's a really high electric bill. Most of your electric bills, I'm going to guess, are probably around $300 or less for the entire month. So $150 a day just to use your microwave is extraordinarily high. Now up here, there was a equation you were supposed to use. The first number was the power rating. So what we should have done for this equation, down here, this one, is taken the power rating, 1,500, times how long we used it for 1 hour, so 1,500, and divided by 1,000, which would have given us 1.5. Then we have 1.5 kilowatt hours. Then we take that times the cost, which is 10 cents. So this right here times 10 cents. 1.5 times 10 cents is 15 cents a day. Okay, 15 cents a day for 30 days. Now we're starting to make sense. It costs $3 to use your microwave every month. $4. That makes a lot more sense. Some of the electric bills that I see you guys getting just for using these things, tens of thousands of dollars a month. I don't know how much money you think your parents make, but if you have a $50,000 a month electric bill, that adds up really quick. So that was just something I noticed in a lot of the ones I was grading. For today, all I'm asking you to do is review some slides, 10 to 21. We're going to talk about alternative sources of energy, renewable energy resources. So let's get that. I'll go over it with you, a little concept map type thing. We have 2 basic learning objectives here. One is to identify and describe various renewable sources of energy. And then 2, which we'll talk more about Friday, explain how a nuclear power plant produces energy. So first, solar, the one we probably have the longest. Radiant energy from the sun, we get it through electromagnetic waves. We can use these by using technology such as photovoltaics. We also use the sun for just heating. If you, in the winter, if you have not an open window that's not had the curtain closed, you can feel that solar energy coming through and heating it up. In 1 hour, the Earth receives enough solar energy that if we are able to harness it all, we could power the entire planet's energy needs. 1 hour. So every day, we're getting 24 times the amount of energy we need for the entire year. We just aren't able to harness it all yet. Here's what some solar power plants look like. We've got these mirrors you can see, all capture the sun, and in the middle here, they focus, they reflect it all right back to here, heat up a giant salt crystal, which then transmits the energy down into the ground, where there's probably a water plant where they boil some water and store the energy that way. You've probably seen some of these. The airport in Indianapolis has rows of lights captured here. These are just capturing energy from the sun and then storing it and then transmitting it when needed. A little smaller scale, street lights sometimes will have these on top of them. Some people have them on their homes, along their walk paths where they got these little cells right here that collect the energy. And I'm sure you're familiar with the solar-powered calculators that have that strip right there. They don't use a lot of light because it doesn't take a lot of energy to put those numbers and calculate on it. So those are the solar cells. Next, we have my favorite one of energy. Oh, I'm sorry, we still have solar. Two types of solar energy when heating a home. One is active, where you are actively capturing the energy from the sun and storing it. You have a cell up here, collects it. Inside it, there's water that runs through it. Heats up the water, and the water is circulated through the home to heat it. So your house is heated through the through the warm water that's been warmed by the sun up here. The second type is passive, which we have all done in cars or homes, where the sun just simply comes through the window and warms up something. So there are two main types of heating a home using solar energy. Now's my favorite. Dam power. Hydroelectricity. Now we see a beautiful dam here that has some water going through it. This is hydropower. This is using gravitational force or flowing of water to get the dam power. What happens is we get some water in here. It rushes through a hole. It has some dam turbines, and it's used to generate some dam electricity. Unfortunately, we are not going to get to the project that I like to do each year. And you're going to miss out on a lot of jokes I have here. Sometimes on these dams, though, we will have a fisherman who likes to catch some dam fish. There's usually a gift shop inside of here where you can buy some dam sandwiches. And a lot of times you'll have a guided tour here. You'll have a dam tour guide walk you through it and tell you about all the dam operations that go on in there. Another type of renewable energy source is biomass, fuel made from living things. Wood was probably the first one we've ever known of. People burned wood, got heat, cooked their food. That was the original biomass. Gasohol is one we've been using a lot more often now, made from corn. You don't see it as often now in stores, but they had the ethanol fuel for flex fuel vehicles. Now, a couple of drawbacks of these. Wood is replaceable, but you cut a tree down, it's going to take 20 years to replace that tree. Certainly doable in our lifetime, but it does take some time. And gasohol, if you've ever seen those gas stations, if you ever paid attention to the prices, we'll say a gallon of gasoline cost $2.83, and the ethanol would cost a little bit less. Problem was, you didn't get as many miles per gallon, so it costs more to use it, and people want to use the cheapest way because, well, we like to keep our money and spend it on things we want, like video games and Robux. Wind power, drive north up I-65, or even really get into west side, you can see some of those turbines we have there. One of the fastest growing energies we have in the United States. It uses turbines by spinning it, and the turbine's connected to a magnet that's rotating around, and that's some coils of copper wire, makes the electrons move, and you get electricity. The nuclear fission also uses turbines. Nuclear fission, these atoms are splitting apart, radioactive decay, and makes a lot of heat. That heat is then used to boil water. Steam goes up and turns giant turbines that have some sort of magnet at the end, spinning around a coil of copper wire, exciting electrons and making them move. Geothermal, using energy from the heat. Geo means earth, thermal meaning heat. Again, making steam, driving turbines. Here is an example of a water pressurized reactor. Typically, you'll see those dome-shaped things. And inside there, we have these control rods that control the amount of heat that's being released. They add water to it as well. The water gets heated up, moves into the heats up this right here, the water in here. This water flashes to steam. The steam is then goes through pipes, spins the turbine. The turbine is attached to this long pole here, and this generator is what makes the electricity and creates it. After which the steam goes into a condenser, cools the water back off, and then is injected back into the system. So the water is used over and over and over here. It's also flowing through here. So that's basically a nuclear power plant, a very general explanation of it. That's all the time we have for today. Please check your grades. Most of the assignments that you've submitted. Also, I have comments and answer keys so you can check to see if you're doing everything correct. We'll talk to you on Friday. Have a good day. Thanks.